Okay, for section 2, 7.2, we're going to actually now talk about how we define probability. All right, now let's think about this. When you're tossing a coin, if you ask the question, what's the probability that a head comes up? Well, there's two possibilities, a head or a tail. So the size of the sample space is two things can possibly happen. Now we ask ourselves the question, what do we mean by success? So if I'm interested, what's the probability that a head comes up? Well, there's only one way that that can happen. So we say 1 out of 2 things. So the way we define probability, it's what is the size of the sample space? And what do we mean by success? How many different ways can we call something successful? Let's take some examples where we go out. So it's not tossing a coin or tossing dice. It's something a little bit more heuristic. You have to go out and take surveys of people. Now, let me just mention something. When you get out in the real world, and just because you've had this course does not mean you know how to create a good survey. Surveys are very difficult to do properly, okay? Let me give you an example. If I ask you to, let's see, deep philosophical question, does somebody prefer M&M's versus Reese's peanut butter cups? Okay. So you go to Walmart and you stop people in the parking lot at 12 midnight, assuming that Walmart's open 24 hours a day. That's a particular sample of people. Whereas if you sample people at, say, 1 o'clock in the afternoon, you're probably going to get a completely different types of responses. Okay, so coming up with a good survey is a very, very difficult thing to do. This course is not intended to show you how to do that. So suppose that we have a small college, oops, pull that down, and it has 1,210 students. That's your universal set. That's all the things that you're concerned with. You're not concerned with a community college someplace in California. It's this specific college. All the students add up to be 1,210. And what we've done is we've found out through the registrar that there are 420 freshmen, 315 sophomores, 260 juniors, and 250 seniors. And that's a reasonable thing because usually you have a lot more freshmen than you do seniors, for example. Now, how do we talk about, we're going to go from these numbers, we're going to use the fact that the size of our sample space is what? All 1,210 students. 420 out of those 1,210, which is what, about 34.7%. So in other words, we're just going to change these numbers into percentages. So if I have 315 sophomores, my sample space is 1,210. Success here means sophomores. 315 divided by 1,210 is about 26%, etc. Now, you better check this. If I take the 410, blah, 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 that better add up to be what? 1,210. And if you also add up these numbers, these probabilities, that should add up to be something close to 1. All right, you're not always going to get necessarily, you may get 99%, you may get 101%. All that means is you had round off here. So don't worry about that. Okay. So suppose we randomly select a student. What's the probability, okay, that something happens? Well, let's take some examples. If I ask, what's the probability that we pick a freshman? Well, how many freshmen did you have out of the sample space? 420 is the number of successes. We're interested in freshmen. If I ask, what's the probability of that I'll pick a freshman or a sophomore? We've talked about that. Or means addition. So I ask myself the question, what does success mean here for 420 out of this? What does success means here? Sophomore, which is 315 out of 1,210. And if I add those up, I get 735 over 1210, which is about 61%. So when we say probability something or something, it means addition. Another example. Suppose I have an ice chest and it contains Pepsi, Coke, Dr. Pepper. Furthermore, each soda comes as either a diet or a regular. All right, so we've gone to the ice chest and we've actually physically measured these guys. Okay, and so what happens is 5% of the soda cans. Notice we're not telling you how many soda cans. We've already converted. Okay, so 5% are Pepsi and they're regular. 17% are Diet Coke. 23% are regular Dr. Pepper. Okay, so what we've done is we took all the cans of soda, not telling you how many are, and then we said, okay, how many are this one? Divide by that number. So when I take these probabilities and I add up all these guys, it better add up to be what? 1. Because sodas have to, the probability of all these has to be 1. So if I take, what I would suggest doing is when you're working with these things, add up these numbers, Okay, so I took 5% and 15, which is what, 20%, plus 23 is 43%, etc. 10%, 30%, plus 17, 57. When I add up this way, I get a 1. Now, do the same thing this way, and this way, and this way. So what I'm doing is I'm taking all the regular sodas and I'm adding them up. All the diets, I'm adding them up, and I should get 1. Now, if I add the number, the percentage, the probability of a Diet Pepsi or a regular Pepsi, I get 50%, etc. When I add up this, I better get a 1, and it's a really good idea to check both ways. Okay, so if I ask the question, what's the probability that I choose randomly, I pick out a soda can and it's Coke. Well, there's 2 ways of picking out a Coke, the regular and the diet, right? So what we're saying is, if I want a Coke, this really means a regular Coke or a Diet Coke, which means you add the numbers. So I take 15% plus 17%. So notice the Coke comes in 2 different flavors, the regular or the diet. If I ask, what's the probability I have a diet, what do I have to do? I have to go along this line, and we've already added it up. That's 57%. And that's where we get this guy. If I ask, what's the probability that we pick a regular Pepsi or a Diet Dr. Pepper? So regular Pepsi is 5%. Diet Dr. Pepper is 30%. So if I add that up, I take the 5% and that's 35%. What's the probability that I do not pick a Dr. Pepper? Okay, what does success mean here? It means I don't choose either the regular or this, which means this is what I'm looking for. This is what we mean by success. So I add up these numbers, and that's where I get the 47%. Okay, let's talk about equally likely events. So suppose I have the sample space is the numbers 2 up through 10, and I ask the question, what's the probability that I'm picking a prime number? Now you remember a prime number is only divisible by itself. So for example, 4 is not prime because you could break it up into 2 times 2. 6 is not prime because 2 times 3. So I ask, first question is, how big is the sample space? Now be careful, 1, 2, 3, 4, 5, 6, 7, 8, 9 objects. Right? If I had put in a 1, then you'd have 10. Be careful of where you're starting. So that means the size of my sample space is 9. What do I mean by success? I want to pick, success means this is the only factors are 1 and 2, 1 and 3, 5 and 1, 7 and 1. So there are what? 4 successful events, 9 possible things that can happen, 4 out of 9. And remember what we're saying here is that picking a number out of here is completely random. We don't have any knowledge of which one is which. They all look alike. Think of them as marbles with a number 2 on it or a 3, etc. So we have no way of distinguishing between them as we're picking. Suppose we roll 2 dice, red and white, and we've looked at this earlier in the semester, since before our time out. And so I'm not going to list out everything that can happen. So if I have 2 dice, they're different. I can distinguish between them. So I have a, if this one's the red, this is the white. So I can have a 1, 1, a 1, 2, etc. all the way up through 6, 5, and then 6, 6. Now, look, what's the size of the sample space? How many faces can come up? 6 is 6. So I know there are a total of 36 things that can happen. So I don't want to list them all out. I know what the sample space is. So a quick way to do that is multiplication principle. I know, now unless the 2 dice are talking to each other, which is not possible, you have 6 things that come up here, 6 to a total of 36. So the size of my sample space is 36. I asked this question, what's the probability that when I add up the 2 dice, I get a 7? Again, we are assuming that the dice do not talk to each other, that the dice are honest, and when I roll them, there's no bias to either one of them. So I know there's a total of 36 things that can happen, but success here means that when I add up the 2 numbers, I get a 7. So let's start out with the simplest. The smallest, the first one could be is a 1, which means this one would have to be a 6. Or I could get a 6 and a 1. Now remember, this is like a red die and this is a white die, so these are different. So there's 2 ways of that. If I kick up the 1 to 2 now, and I want it to add up to 7, this has to be a 5, or I can reverse that. If I go 3 and 4, I could flip that because the dice are different. Now if I try to go up to 4 and 3, I've already counted that. So in other words, 5 and 2, etc. We've already counted those guys up here. So the size of the sample space is what, 36. There are 1, 2, 3, 4, 5, 6 ways of doing that. So 6 out of 36, which is 1/6. That's how we calculate probabilities.